This is Jeremy Candelosas, and in this video lesson, we will be discussing conversion of units. So to begin with, conversion of units, or the conversion between different units of measurement for the same quantity, typically through multiplicative conversion factors. The conversion factors are the factors that change the unit in a number without changing the value of measurement. Here are some examples of the conversion factors that you will be needing later for some exercises. Speaking of measurement, there are two major systems of measurement, namely the English and the metric system. The English system originated from United Nations and is rather an older system compared with metric system. Some of its units were inches for length, ounces for mass, pint for volume, and more. On the other hand, metric system is a system of measurement that succeeded the decimalized system based on the metric introduced in France in 1790s. Its base units were gram for mass, liter for volume, meter for length, and more. The metric system also uses prefixes for either very large or very small numbers. The SI system, or the System International, is a modern form of metric system. It is the only system of measurement with an official status in nearly every country in the world. Its base units were meter, kilogram, second, ampere, Kelvin, mole, and candela that measures length, mass, time, electric current, temperature, amount of substance, and luminous intensity, respectively. Okay, now let's have some sample exercises about conversion in mass. Okay. A person's average daily intake of glucose is 0.371 newtons. What is the mass in pound, in gram, and in kilogram? So if we will be looking back for the conversion factors table a while ago, we can see that there is a factor that will convert newton to pounds. So write it in an equation form like this, and as you can see here, that factor is 1 pound is equivalent to 4.45 newtons. So now we will be canceling out the like units, and then we will solve. So 0.371 multiplied by 1 divided by 4.45, the answer will be 0.083 pounds. Now, if you cannot find any direct conversion factors, you can always use the pre-existing value in order for you to arrive for the right answer, like this. As you can see, the conversion factor of pound to newton is still present. It is because there are no conversion factor of newton to gram or gram to newton in our table. So once again, just cancel out the like terms, the newton and then the pound, because we only wanted the gram unit, and then we'll just solve. 0.371 multiplied by 1 divided by 4.45 multiplied by 453.6 grams divided by 1, the answer will be 37.82 grams. And in kilograms, this is how you do it. So as you can see, in a kilogram, as you can see in here, a kilogram is equivalent to 2.206 pounds. So that is the conversion factor that we will be using, as well as the pound to newton or the newton to pound, just like in grams. So again, cancel out the like units, the newton, and then the pounds. So we will be left out with kilogram. And again, solve the equation, and then we will arrive to the answer 0.038 kilograms. Okay. Okay, now so let's convert some units in volume. So An average adult has 5,200 cubic centimeter of blood. Now, what is the volume of blood in gallon, in milliliter, and in cubic meter? So, again, just plug in the needed conversion factors from the table. Again, if you cannot see a direct conversion factor that will convert the given unit into the unit that is needed, you can always use different conversion factors in order for us to arrive with the answer. So in here, first we converted centimeter cube into milliliter, then the milliliter into liter, and finally liter to gallon. So just solve for the operations needed, and then we will be arriving to the answer 1.37 gallon. So it seemed to be easy because as you can see, this centimeter cube, the liter, the milliliter were from the metric system, which typically uses or use conversion factors of either tens, hundreds, so there are no a lot of numbers that you needed to remember, unlike in English system. So by the way, this is an conversion of English system. Gallon. Gallon is a unit of volume in English system. So next, as you can see here, this is a very short one. So 5,200 cubic meter to milliliter, you'll just needed to cancel out the centimeter cube, and then what was left for us was the milliliter, and that's the answer. So solve the problems, or the equation rather, and we will arrive to 5,200 milliliters. And that's it. Now, for the SI system, okay, as you can see here, there's a lot of ones and zeros in here, and there is two ways of answering this type of conversion. So this is the first one. So again, plug in the needed conversion factors, and then do the operation, solve them, and then cancel out the like terms. Okay, after we have canceled out the like terms, we will be arriving at the answer 0.052 meter cube. Now, this is the second way of it, and is the easier way of answering this for me. So in here, as you can see, this conversion factor of 1 meter is equivalent to 100 centimeter was placed in a parenthesis and raised into the power of 3. Why? Because the centimeter cube, or the cubic centimeter, is needed to be converted into meter cube. So instead of using different conversion factors or a lot of conversion factors like here in the first example here, so we will be cubing these conversion factors that will be equal to this, since we have cubed this conversion factor. So 1 meter over 100 centimeter cube will be equal to 1 meter cube over 1 million centimeter cube. So you'll just solve this and this, and that's it. We will get the same answer. Okay? Okay, so now we will be converting density. So The density of silver is 10.5 gram per cubic centimeter. Now convert the density to pound per cubic feet, gram per milliliter, and kilogram per cubic meter. So as you can see, there are already two units that are needed to be converted, the gram and the cubic centimeter. So here is a way to convert them. So as you can see, we have used the pound to gram conversion factor so that we can cancel out the grams, and we will be left with pound. And then next we will, since we have already, or we successfully converted the gram into pounds, we will be now doing or converting the cubic centimeter to cubic feet. So remember that if we will be converting a cubic unit in volume or in anything, the conversion factor should also be in cubic unit. So as you can see, there is this conversion factor that has been placed inside a parenthesis and raised into 3, so that the centimeter and the feet units will be raised to 3 accordingly. So 30.48 centimeter is equivalent to 1 feet. So we will be raising everything into the third power. So the 30.48 centimeters will be 28,316.84659 cubic centimeter or centimeter cube over 1 feet cube or 1 cubic feet. And then after that, we'll be using this. So we'll be solving out the needed operations, and we will be arriving to the answer 655.48 pound per cubic feet rather. Okay, so now to grams per milliliter. As you can see here, since we will be converting it to gram per milliliter, and the first unit in here was grams, so it means to say that we are not going to have to convert the gram into anything anymore. So what we will be converting is the cubic centimeter, and in the table of conversion factors, 1 cubic centimeter is equivalent to 1 milliliter. So the answer will be 10.5 gram per milliliter. Okay, here, the kilogram per cubic meter. Okay, so as you can see, there are a lot of ones and zeros again in here. So there are also two ways of solving this, just like the first one in the volume. So I'll be showing you the both conversion processes. So just fill up the needed conversion factors in order for us to cancel out the terms. So the grams, as you can see, and then we will be left with kilogram, which is what we needed. And now the cubic centimeter. Okay, we'll be canceling this out, this, the ml, and the liter, and we will be left with 1 meter cube. So again, just solve, and after we have solved, we will be arriving at the answer 10.5 kilogram per meter cube. Okay, so this is the second way of answering this. As you can see, there is this conversion factor that has been placed again in a parenthesis and raised into the third power. So just like in volume a while ago, we will be also solving this accordingly. We'll be putting the conversion factors, canceling out the like terms, grams, and then the cubic centimeter. As you can see in here, we haven't used the ml and L, or the milliliters and liter conversion factor. Instead, we've used centimeter to meter, and then we place it in a parenthesis and raised both by the third power. So as you can see, we had arrived at the same answer. So that's it. So now we will be converting temperature. Mercury, the only metal that exists as liquid in room temperature, melts at 421.65 degree Rankine. Now convert its melting point to degree Fahrenheit, degree Celsius, and Kelvin. So here are the conversion factors for it. So degree Celsius is equal to degree Rankine, subtract by 491.67, then multiplied to 5 over 9. The degree Fahrenheit is equivalent to degree Rankine, subtract to 459.67, and the Kelvin is the degree Rankine multiplied by 5 over 9. So we'll just simply substitute the amount of, or the value of degree Rankine into those, what you call this, equations. So first, the Fahrenheit, so the value of Rankine, 421.65, subtracted by, or subtracted to 459.67, the answer will be negative 38.09 degree Fahrenheit. And then next, degree Celsius is equals to 421.65 minus 491.67. Then multiply it to 5 over 9. The answer will be negative 38.9 degrees Celsius. It's quite cold, but still the mercury already melts rather. So next is to Kelvin. So 421.65 multiplied by 5 over 9. The answer is 234.25 Kelvin. And that's it. But remember that there is also another conversion factor for Celsius to Fahrenheit, Celsius to Kelvin, Fahrenheit to Celsius, Fahrenheit to Kelvin, and more. But let's keep it for now. So now we will be converting the concentration of a solution. So 25 grams of isopropanol is dissolved in 45 grams of water. What is the concentration of isopropanol in parts per million? Then convert it into pound per cubic feet, grams per liter, and mole per liter. So first, we will be solving the concentration of the isopropanol in parts per million. So this is how you do it. Just simply divide the mass of the solute to the mass of the solvent, and then multiply it in 1 million, or 1 times 10 raised to 6. So the answer would be 5.56 times 10 raised to 5 parts per million. So now we will be converting the parts per million into pound per cubic feet, grams per liter, and mole per liter accordingly. Okay, here. 1 ppm is equivalent to 6.24 times 10 raised to negative 5 pound per cubic feet. So 5.56 times 10 raised to 5 ppm multiplied by 6.24 times 10 raised to negative 5 pound per feet over 1 ppm. The answer would be 34.69 pound per cubic feet. So again, canceling out all the like terms, That's it. Next, the grams per liter. So 1 ppm is equivalent to 1 times 10 raised to negative 3 gram per liter. So again, we'll just cancel out the like terms, and then after that, we'll just go on with the solution, or the equation rather, the solving part, and then we will arrive at the answer 556 gram per liter. And that's it. And for the last, the mole per liter, 35,500 ppm is equivalent to 1 mole per liter. So again, just cancel out the like terms. After that, we will be solving the needed operations that will lead us to 15.66 mole per liter. And that's it. Now, we will be converting parts per billion. So a while ago, we have answered or converted units in parts per million. Now it's parts per billion. Okay, so here's some example. Suppose 17 grams of sucrose is dissolved in 183 grams of water. What is the concentration of sucrose in ppb, or parts per billion? Then convert it to, again, pound per cubic feet, grams per liter, and mole per liter. So we will be answering or solving the concentration of sucrose in parts per billion. So here's how you do it. Again, you'll just need to divide the grams, or the mass of the solute onto the mass of the solvent, and then instead of multiplying it to a million, or 1 times 10 raised to 6, now we will be solving it, or multiplying it rather, to a billion, or 1 times 10 raised to 9. So we'll just go on with solving the operation. The answer would be 9.29 times 10 raised to 7 parts per billion. Now we will convert this to pound per cubic feet, grams per liter, and mole per liter. So a pound per cubic feet is equivalent to 1 times 10 raised to 7 parts per billion. So cancel out the like terms, and then we'll just have to solve everything that is left. 9.29 times 10 raised to 7 multiplied by 1, then divided by 1 times 10 raised to 7. The answer would be 5.81 pound per cubic feet. Next, a gram per liter is equivalent to 1 times 10 raised to 6 parts per billion. So again, we'll just have to cancel out the like terms and go on with the operation. Solve it. 9.29 times 10 raised to 7 multiplied by 1, and then divided to 1 times 10 raised to 6. The answer would be 92.9 gram per liter. And that's it again. And for the last, the mole per liter, since there is no direct conversion factor for this, we will be converting the parts per billion into parts per million first, before converting it into a mole per liter. So 9.29 times 10 raised to 7 parts per billion. So we will be canceling out the parts per billion in here, because a parts per billion is equivalent to 1 times 10 raised to 6 parts per million. So it has been cancelled. Also, the ppm will be cancelled, or the parts per million unit. So the unit left was mole per liter. So now go on to the solving part. 9.29 times 10 raised to 7 multiplied by 1 times 10 raised to 6 divided by 1 multiplied again by 1 and then divided to 35,500. The answer would be 4.19 times 10 raised to 9 mole per liter. And that's it. That is how you convert um, parts per billion to different units. Okay, that's it. That is how you convert units. Thank you for listening.